welcome to the next section of geometry. We're going to move into chapter 9 next after the midterm exam. But before we get into chapter 9, we're going to review a couple of things that you should have covered in Algebra 1, but might not have gotten to with last year ending early. So we're going to kind of go over the process of what it means to reduce radicals, how to combine radical expressions. So like when we have a square root, how do we simplify it down? How do we combine it with other square roots and things like that? So today, we're just going to kind of discuss how to simplify and then how to add and subtract square root values. So the first thing, you are going to need to memorize this list of perfect squares. And so this is a list where every assignment you get, I would write this list of squares at the top every single time, because it's going to do two things. It's going to give you the numbers that you can use on the assignment itself, and every time you write it down, it's going to help you to commit those numbers to memory, because these numbers are going to play an important role throughout this entire chapter. So when we talk about perfect squares, what we mean, like when we're looking at this list, so we're saying that 4 is a perfect square. Well, so if I take the square root of 4, like we see here, I get a whole number result, like 2. Or if I take the square root of 16, so we got 16 up here in the list, the square root of 16 is 4, and the square root of 25 is 5, and the square root of 100 is 10. So every time I take the square root, I get a whole number answer. And so as we're looking at this, the perfect squares, again, things to think about is like with 4, that's like saying 2 times 2. Or like 36 is 6 times 6, so it's a number multiplied by itself to get that number. So as far as memorizing this list, what you might be able to do to kind of help your process is just understand that this list is nothing more than 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. So if I just want to create this list every time from scratch, all I got to do is start at 1, multiply it by itself, then 2, then 3, then 4, then 5, up to however far I need to go. So these numbers, like I said, are going to be numbers that you need to know. And so you can create them from scratch or memorize them, whatever seems to work best for you. Now, as far as simplifying radicals, so up here, if I go back to it for a second, the perfect squares, when we take the square root, they're going to reduce automatically. So square root of 4 reduces down to 2. The square root of 100 reduces down to 10. Like perfect squares just come out to the whole number and we're good to go. But there's times where we get numbers that are not perfect squares. So for example, we see the square root of 8 here. Well, 8 is nowhere in our list up above. And so when we look at a problem like this, we need to look to see, can I take that 8 and break it down and simplify this problem, or simplify the number? And so when we simplify, we're going to break the original number up into 2 factors, 2 numbers that we multiply together to get that number. So like 3 and 2 are factors of 6. So 3 times 2 gives me 6. Those are factors. What we want to do, though, is make sure that we identify the largest perfect square that goes into the number that we're looking at. So we want to try to find the largest value from this list that we have at the top of our sheet that goes into that number. So for instance, if I'm looking at the square root of 8, I'm going to look at this list. Now I can't have a number bigger than 8, because if I try to divide 8 by anything, it's got to be something smaller. So I can start right here, and I'm just going to go work my way down the list. So if I take 8 divided by 4 in my calculator, I get 2. So that's what you see right here. We break it down. I divided by 4 and I got 2, so I use those 2 numbers. So square root of 8 can be rewritten as the square root of 4 times 2. Now at this point, the 4 is a perfect square. We just said on the last slide that the square root of 4 is equal to 2. So that's what's happening as I go from here to here. The square root of 4 is 2. Now, my 2 that's in there as well, so this 2 right here, isn't a perfect square, which means it stays right where it's at inside the radical. So as we're simplifying these radicals here, we're trying to find what's the largest perfect square that goes into my number, and then what's left over when I divide. And then I'm going to use those 2 numbers and try to break down this radical. So if we take a look at some examples here, we'll start off pretty easy with the square root of 20. Now, if I'm looking at the square root of 20, I need to look at my list of perfect squares. I want numbers less than 20. okay? And as we do this more and more, some of you are going to start to become a lot more comfortable with this process, and you're going to start to be able to identify the numbers a little bit easier. But if you're having trouble identifying what to divide by, start with the biggest number less than yours. So we're at 20, we want to be everything less than 20. So if I go into my calculator, if I take 20 divided by 16, that's my first number. I get a decimal. I don't want decimals. So I ignore 16. Now I go to 9. So I'm going to get rid of 16. I don't want that option. So if I take 20 divided by 9, I get another decimal. I don't want that. And I'm going to take 20 divided by 4, and I get 5. There's my answer. So instead of looking at 20, I divided by 4, and I got a leftover of 5. So 4 times 5 is equal to 20. And then just like we did on the last slide here, the square root of 4 is just 2. So that's a perfect square. So this square root of 4 becomes 2. The 5 is not a perfect square. It's on our list, and it can't be broken down anymore, which means the 5 stays exactly where it's at in my radical. And so I find out that I get my final answer of 2 square root of 5. Okay. If we go to some other numbers here, so let's go to this next example, square root of 75. Now for square root of 75, again, I look for my numbers in my perfect square, so 64 is my biggest number less than 65 or 75. And so if I start working my way down the list, 75 divided by 64, decimal, I don't want it. 75 divided by 49, decimal, I don't want it. 75 divided by 36, decimal, I don't want it. But then if I use 75 divided by 25, I'm left with 3. So there's the number I want. So it's my first time I don't get a decimal, so I had 25 times 3. And then again, from here, 25 is my perfect square, so square root of 25 is just 5. That comes on the outside. 3 is not a perfect square, so it stays inside. And so we got 5 square roots of 3 for that square root of 75. Okay, and then we just kind of work our way down the list here. So we'll do another one, or do a couple more here. So square root of 48. With 48, I'm going to start with the lowest, or the number lowest than that. So start with 36, and I'm going to work my way down the list. So 48 divided by 36 is a decimal, don't want it. 48 divided by 25 is a decimal, don't want it. But 48 divided by 16 gives me 3. So I'm going to rewrite this as 16 times 3. And then 16 is a perfect square. When I take the square root, I get 4. 3 is not a perfect square, so it stays inside, and we get 4 square roots of 3. And then we continue that process for any number. So for any number that we're working with, we just work our way down the list until we get one that works. Now, in the off chance that you get something like, let's say, square root of 79. So we're going to try to reduce this number here. Well, 79, I choose the numbers less than that. And so if I start going down my list, 79 divided by 64 is a decimal. Divided by 49 is a decimal. Divided by 36 is a decimal. Divided by 25 is a decimal. Divided by 16 is a decimal. Divided by 9 is a decimal. Divided by 4 is a decimal. And so what we notice is we have to go all the way down to 1 before we find any sort of perfect square. And 1 isn't a useful perfect square because it just is the number by itself. So in a situation like this, the square root of 79 is just as low as it can go. There's nothing that divides into it, so we just leave it alone and call it good. The other thing to think about would be like if you get a number like square root of 10. Well, so if I'm looking at the square root of 10, yes, the square root of 10 could be written as 5 times 2. Like it does break down into smaller numbers where 79 didn't, but if I'm looking at this, neither 5 nor 2 is a perfect square. None of that's in my list up here. So if I can't break it down into a perfect square, then I don't break it down at all. I'm not going to break it up into 5 and 2. And in that case, the square root of 10 is as low as it goes. So in order to break it down, it has to be a number from your list. And that's why this list is so important. I want you to write it down on every assignment. Because if you can't break it into that list, you can't proceed. Now, if we look at a combining radicals. So we're going to talk about adding and subtracting. So in order to combine radical expressions, it's just like when we added like terms in an equation. So if I had 5x plus 2x minus 3y, and I said simplify that expression. Well, you would take the 5x and the 2x because they're like terms, and you would combine them. So 5 plus 2 is 7x. The 3y is all alone. It has nothing to combine with, so we just leave it as minus 3y. Well, the same idea is going to apply to radicals. Whenever I'm working with radicals, if they have exactly the same radical expression, then they're considered like terms. So what I'm looking at in this example is I have 6 square roots of 7, 5 square roots of 7, and 5 square roots of 2. Well, if I look closely, then I have square root of 7 and square root of 7. Those terms are alike. So I'm going to take the numbers on the outside, 6 and 5, and add them together. That's where my 11 comes in. And then the square root of 7 just comes along for the ride, just like x. If this was 6x plus 5x, we would write 11x. So we just use the square root of 7 instead of x now. The 5 square root of 2. That square root of 2 has nothing to match with, so it just comes along for the ride, and we get this overall answer, 11 square roots of 7 minus 5 square roots of 2. If we have numbers that need to be simplified, though, so notice in this equation, 2 times the square root of 50 plus 3 times the square root of 32. 50 and 32 can be broken down. So 50 becomes 25 times 2. There's my perfect square. Well, if I have that perfect square of 25, that becomes 5 times the 2 that was already on the outside, and I get 10. And then since the square root of 2 is not a perfect square, it just comes along for the ride inside the radical. So I end up with 10 square roots of 2. When I look at the second term here, 32 breaks up into 16 and 2. 16 is my perfect square, so I can bring it out as 4. The square root of 2 is not a perfect square, so it stays inside. And then I had a 3 on the outside already, so 3 times 4 is 12. Square root of 2 just comes along for the ride. And then now I have a square root of 2 and a square root of 2, so I can combine like terms. 10 minus 12 is negative 2, with the square root of 2 coming along. So if we look at some examples, when we get a problem where nothing simplifies, so we have 5, 6, and 6 here. Nothing simplifies in the radical, so at this point we can just look for like terms. So the square root of 5 has nothing to match with, so I'm going to leave it alone and just bring it along. So 6 square roots of 5. But then I notice that I have 2 square roots of 6, so this one and this one have a square root of 6. So I'm going to take the 5 minus the 3 on the outside. So 5 minus 3 is 2, and then bring the square root of 6 along. And so then my final answer is 6 square roots of 5 plus 2 square roots of 6. In the second example, we notice that 24 and 54 can probably be broken down. And so if I look through my list, what's going to happen here is 24 can be rewritten as 4 times 6. I got my square root of 4. So the square root of 4 is 2 times the 3 that was outside. So I get 6, and then my square root of 6 just comes along for the ride. So the 6 is not a perfect square, it just comes along. When I look at the second one, I have 54, which can be broken into 9 times 6. 9 is my perfect square, so I can take the 9 or square root of 9, which is 3, and then the 6 stays inside. And then if I multiply the 7 and the 3, because they're on the outside now, I get 21 square roots of 6. And then since I have a square root of 6 and a square root of 6, I can add the numbers on the outside. So 6 plus 21 is 27 square roots of 6. When we look at the last example, again, just kind of simplifying things down. So I've got my 2. 8 is going to be broken down into 4 times 2. The square root of 4 is 2. So when I bring that 2 on the outside, 2 times 2 is 4. And then I have a square root of 2 that's left inside. When I look at my second one, I've got 48, which can be broken into 16 and 3. We did that one earlier. The 16 is a perfect square. So the square root of 16 is 4 times the 6 that's already outside, and I get 24 with the 3 stuck inside. So 24 square root of 3. Now, when I look at the result here, I've got a square root of 2 and a square root of 3, which means I have unlike terms, and so I cannot combine them in any way. So I just leave my answer as it is. So, with that information and with those examples, you should be able to complete the worksheet for today. So make sure you get that in class, or get it off of Google Classroom and write your answers down. If you have questions, make sure you ask in class or email, or check the answer key as it becomes available.